Molecular compounds. So molecular compounds have a metal, two nonmetals, right? If it's got a metal in it, it's an ionic compound. So here we just have nonmetals. We can't figure out the formulas from the charges on the ions because there aren't any ions. And you can't just know what the compound between nitrogen and oxygen is because there's a whole bunch of them. So just an example, between nitrogen and oxygen, there are 6 different molecular compounds. They can be nitrogen and oxygen combined in 6 different ways. So each of these needs its own name, right? So that we need one name corresponding to one formula. So what we're going to do here is we're going to use those numerical prefixes again, and we're going to use these to indicate how many atoms of each element there are. So reminder that we're talking about 2 nonmetals here. Who goes first in this in the compound? Well, it's the one that's more metallic. Well, how do I know, nitrogen or oxygen, which is more metallic? They're both gases. None of them seem metallic. Well, let's look on the periodic table. We know that the nonmetals are on the upper right side and the metals are on the lower left side, and there's that stair-step line. So the trend is from the left to the right, it's less metallic. From the top to the bottom, it's more metallic. And so if you're, say, looking at nitrogen and oxygen, who's closer to the metal side? Nitrogen. So nitrogen's going to go first. Because the pattern with the ionic compounds was the metal goes first and then the nonmetal, right? Here we've got 2 nonmetals, but we still need to choose which one to go first. So we choose the one that's more like a metal, even though there isn't a metal, okay? So these are the prefixes. So we've got a prefix and then the name of the first element, because just like the pattern with the ionic compounds, a cation doesn't change its name. And so here we're pretending like this one is a metal, sort of, and so it's just the element name. And the pattern for the monatomic anions was that they changed their name, like chlorine became chloride. And so here we have a prefix, and this ending one, the last one, does change its name. So they're kind of like pretending that it's a metal and a nonmetal, but they're not. So prefix, element name, prefix, element name with the ending changed to "-ide". So just like we eliminate or don't write the number 1 in many situations, we also eliminate mono, the prefix for 1. So generally, if the first element, there's only one of that, we leave the mono off of that. So this compound, NO2. So this is the first one. It's nitrogen. So that's the name of the first part. And then the second one is oxygen. We change the ending to oxide. And then we have to specify how many there are. So it's dioxide. Any questions? These are 2 that always use their common names. Yes, because they are so common. So H2O, you could call it dihydrogen monoxide. And, if you want to scare somebody, say, my teacher made us drink dihydrogen monoxide in chemistry lab today. I thought I was going to die. Yeah, I said, go get a drink of water. You're coughing too much. NH3, the systematic name for that would be nitrogen trihydride, right? And it's not that that's incorrect, but nobody calls it that. Everybody calls it ammonia. What's the formula for the ammonium ion? NH4 plus. That's ammonium. See the relationship there? This is an ion form of ammonia. So ammonia is NH3, ammonium's NH4 plus, water is H2O. I expect you to know those guys. So let's name this compound. Oops. So what's the name of the first element? Nitrogen. And how many are there? 2. So di-nitrogen. And the name of the second one is oxygen. We changed it to oxide. And what's the prefix for 5? Penta. So pentaoxide. Now, sometimes when you get these 2 vowels in here, it gets a little awkward. Like carbon monoxide. So carbon monoxide is spelled like that. What we're meaning is carbon monoxide. But that double O business is just weird, isn't it? So sometimes when we have a prefix ending in a vowel and the element name starting with a vowel, sometimes that last letter on the prefix is dropped, like in monoxide. I will not try to trick you with that one, okay? So if you were filling out a worksheet or something and it wasn't a multiple choice thing and you wrote pentoxide and I was expecting pentaoxide, I would count both of them correct. Because that's one of those things that there is an official correct name, but most chemists are a little bit unclear on that, and we just don't care about that very much. If I was giving you a multiple choice test, I would not put pentaoxide and pentoxide and make you choose the correct one, because that would be mean. And I may be a hard teacher sometimes, but I am not mean. I am not out to get you. I do want you to be successful. So I'm not going to trick you with that one. Okay, let's write the formula for phosphorus tribromide. Phosphorus is what? P. And tribromide, Br3. Those seem easy compared to the ionic ones? Yeah. That's why this section's really short, because there's just not that much to say. So now that I've showed you that, you're going to be tempted to use those prefixes all over the place. You can't use them with ionic compounds. The only place they come up with the ionic compounds is if you have a hydrate, and we're not going to see very many of those. So if there's a metal in there, don't use the prefixes, okay?